Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there, though all children are welcome to tune in. This lesson is the 8th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee at Laverne Middle School in Rutherford County. I'm so excited to be your teacher today. Welcome to my virtual classroom. If you didn't see any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and look at previous lessons since we might be talking about things previously learned today. Today we review dividing fractions, including mixed numbers. All right, so here's our problems. So I want you again to write a division sentence and draw a visual model to show each problem. A, 8 gallons of batter are poured equally into 4 bowls. How many gallons of batter are in each bowl? B, 1 gallon of batter is poured equally into 4 bowls. How many gallons of batter are in each bowl? And C, 3 gallons of batter are poured equally into 4 bowls. How many gallons of batter are in each bowl? So take your time, and I want to know what you notice and what you wonder. So, what similarities do you notice about the 3 scenarios? I agree. One of the similarities is that they all contain 4 bowls. Let's look at what that might look like as a model. So, let's look at A. Draw these 4 circles for this problem. So those first circles represents the 4 bowls. Between my 3 problems, did you notice any differences of the 3 scenarios? Between those 3 problems, did you notice any differences between the 3 scenarios? Correct, the batter is divided into different amounts in each scenario. So starting with the first one, I have my 4 bowls, and now I'm going to divide my 8 gallons equally into the 4 bowls. So I know I have 8 gallons, and I'm about to divide them equally into our 4 bowls. So how much would each bowl get? How many gallons? Well, this bowl will get 1 gallon, and then another gallon. So this bowl gets 2 gallons. This bowl gets 2 gallons. So each bowl gets 2 gallons. So what is our division sentence for this? Correct. Our division sentence should be 8 gallons divided into 4 bowls. All right, let's look at the next one. B, again, was 1 gallon of batter is poured equally into 4 bowls. How many gallons of batter are in each bowl? So this one I'm going to divide up. I'm dividing 1 gallon into 4 bowls. So this bowl will get 1/4 of a gallon. This bowl will get 1/4 of a gallon. This bowl will get 1/4 of a gallon. And this bowl will get 1/4 of a gallon. 1/4 plus 1/4 plus 1/4 plus 1/4 will give me my 1 gallon. So how can I write this one as a division sentence? Yes, 1 gallon, I'll make sure I write my units with it, divided by 4 bowls. Good job. Let's look at the last one, C. I have 3 gallons of batter are poured equally into 4 bowls. So 3 gallons into 4 bowls. I want to know what is how would I divide this into my model? Correct. Each bowl will get 3/4 of a gallon. So 3 gallon, fourths gallon, 3/4 gallon. Good job. So now what's my division sentence that will go with this problem? Correct. It is 3 gallons divided by 4 bowls. Great job. So one thing I want to point out that I did was I made sure for these problems I had gallons, bowls, gallons, bowls, gallons, bowls. We're going to come back to that. So as we look at these models, we notice that dividing by 4 and multiplying by a fourth are equivalent. We will build on this fact as we divide fractions today. Today, we're going to compute quotients of fractions. We will dig into mathematical representations of dividing fractions by using common denominators. We will use the terms dividend and divisor. Again, we will use the term dividend and the term divisor. Throughout the lesson to refer to the division expression. Remember, the dividend is the number being divided. So our dividend is our number being divided. So what is our divisor? Correct. It's the official name of a number that is being divided into another number. Good job. So, for example, if I had 55, I don't want to use that. $55 divided by 11. 55 would be my what? Correct. It'll be my dividend. And 11 will be my divisor. So what would the quotient be? Correct. My quotient will be 5. I'm so glad you remember those terms. So let's apply and extend previous understanding of division to divide fractions. All right, students, I want you to find the quotient for each example in the sequence. Find the quotient for each example in the sequence. All right, so let's check those answers. So 8 divided by 2 is 4. 8 ones divided by 2 ones is 4 ones. 8 tens divided by 2 tens is 4 tens. 8 thousands divided by 2 thousands is 4 thousands. Oh, are y'all seeing the pattern? 8 tenths divided by 2 tenths is 4 tenths. And 8 thirds divided by 2 thirds is 4 thirds. Wow, so we see that the quotient for each example is 4. Why do you think this is true? Yes, it's because we are working with the same units. So for this one, even though here I have the same units of 1, here I have the same units of tens, units of thousands, tenths, and thirds. Remember, units represent a quantity. For us, the units will be represented by the denominator, since it tells us how many groups a whole number is divided into. Since the units are the same in each example, the basic fact is that 8 divided by 2 gives me 4. The 8 divided by 2 gives me 4. Where 8 was the dividend each time and 2 was the divisor. Each time this gives us the same quotient of 4. This will hold true anytime we are dividing with the same units. Why? It's because the denominator of each fraction represents a whole unit, while the numerator represents the part of the unit. Let's see how this looks with fractions. If I had 8 thirds, or 8 divided by 3, divided by 4 thirds, I know that is 8 thirds that I'm dividing by 4 thirds. So again, my units for this problem is thirds, which will represent my denominator. So now I can take my numerators, 8 divided by 4, to give me 8 divided by 4, which will just give me 2 as a quotient. We'll work a few of these and make sure to note that the units each time. So in each of these, I'm gonna throw up some problems. I want you to make sure you note the units for each problem. So here's your problem. What would be the units for each of these problems? So let's start with the first one. I have 10 sevenths divided by 2 sevenths. So that is the same thing as me saying 10 sevenths divided by 2 sevenths. My denominators and my units are the same. So that's my sevenths. So now I have 10 divided by 2, which is going to give me what? 5. Good job. Let's look at the next one. I have 28 thirds divided by 7 thirds. So that's the same thing as me saying 28 thirds divided by 7 thirds. Still the same. So now I can look at my numerators. So that's the same thing as me saying 28 divided by 7, which is going to give me what? 4. Good job. Let's do another one, the last one. This is 4 fifths divided by 2 fifths. Same thing. So my numerators is 4 divided by 2, which is just going to give me what? 2 as an answer. Good job. All right, students, let's look at this problem. If we are asked to divide 18 fourths divided by 5 fourths, what do you notice? You're right, 5 does not divide evenly into 18. Let's see what happens when the divisor does not divide evenly into the dividend in the numerator. So I'm going to write this out. 18 fourths divided by 5 fourths. Still the same. Now I can write this as 18 divided by 5, or 18 divided by 5, since it doesn't come out. I know that it doesn't come out evenly. So what can I do with this fraction? I can also write this improper fraction as a mixed number, since 5 is not a factor of 18. That would make this 18 fifths equivalent to the improper fraction, or the mixed number, of 3 and 3/5. You remember that from 5th grade? Isn't that cool? So students, I also want you to notice that the denominator in each of the fractions that we've been working with is the whole unit, and the numerator in each of the fraction is the part of the unit. And all these examples, our dividends and our divisors, have the same units. What do you think we can do if our denominators do not represent the same units? So if our denominators did not represent the same units, I think you're right. We can write equivalent fractions to find like denominators. We did this in 5th grade to add and subtract fractions. So let's build on that skill. To find equivalent fractions, we must multiply the numerator and the denominator by the same unit. Again, to find equivalent fractions, we must multiply the numerator and denominator by the same unit, by the same number. We will be intentional to find an equivalent fraction with the same units as our divisor. So let's practice some more problems. Y'all ready? All right, here we go. So here's our next problem. Why can't we begin dividing? You're correct, because right now the first fraction has a whole unit of 4, where the second fraction has a whole unit of 8. How can we make sure they have the same unit? I agree. Let's see how we can use equivalent fractions to rewrite 11/4 with 8. What can I multiply 4 by to get 8? Correct. I can multiply that by 2. So I'm going to multiply this, my denominator, by 2. And since I'm multiplying, I have to make sure I multiply both my denominator and my numerator by 2. Remember to create that equivalent fraction. So 2 times 11 is going to give me what? 22. 2 times 4 is going to give me 8. So I know that 11/4 is equivalent to 22/8. Good job. So now looking at my problem, 22/8 divided by 3/8. Do I have the same denominator? Yes. So I know that this is the same thing as 22/8 divided by 3/8. Same. So I can do 22 divided by 3. Does that go in evenly? No, so I can create my mixed number. So that's the same thing as having 7 1/3. Y'all are doing good today. So let's look at this next problem. How does this problem differ from the others we have done today? You guessed it, it has a mixed number and they don't have the same denominator. How do you think we can take care of that? Right, changing the mixed number to an improper fraction would be our best start. So let's change this mixed number to an improper fraction. So I know I have 3 1/2, And I'm going to change that into an improper fraction. What's my improper fraction I'm going to change this to? Correct. 7 halves. We can use this now as our dividend. So I have 7 halves divided by 3/4 equal. What can we do now to get common denominators? I agree. Rewriting the dividend as an equivalent fraction with a new denominator will allow us to have the same units or denominators. What are the same units or denominators we want? So what do we want to make sure we work with? Correct. Let's turn this into a 4. So I'm going to multiply this, my denominator, by 2 to get 4 as my new unit or denominator. Remember, if I do it to my denominator, I've got to multiply my numerator to make it equivalent. That's going to give me 14. So now I have like denominators. So now we're ready to solve. So 14/4 divided by 3/4 is going to give us, I can write this, 14/4 divided by 3/4, which is the same thing as 14 divided by 3. Remember, units are the same. Or, since I know that that doesn't come out even, I can go ahead and turn this into a mixed number. So give me 4 2/3. Good job, y'all. Let's remind ourselves of what it means when we started today in the earlier lessons at looking at models. So let's look at some models. Let's look at a bar model of this division problem to make sure we really understand what our answer means. All right, students, take a look at this bar model. How does this connect to the work we just did to get 4 2/3? Correct. The bar model shows 14 quarter hours of, or 14/4. The dividend in the problem is 14/4, and the divisor is equal to 3/4. So 14 can be divided by 3 to find the number of 3/4 in 14/4. In this situation, what does the 4 2/3 mean? Right, to show us that when we divide 3.5 into sections of 3/4, we have 4 2/3 of them. We may not always be asked to draw a visual, but we can always have a tool when we want to confirm or clarify our solution. Now we're going to do one more. We haven't seen what happens if we have a whole number in the divisor of the expression. So let's start working this out. Where do we begin? Correct. Let's start with making sure that both terms are fractions. So to write 6 as a fraction, that is 6/1. So now my problem is what can we do now to get common denominators? We can rewrite the dividend as an equivalent fraction with a new denominator, and this would allow us to have the same units. So what can I multiply this by to change my denominator to match my other denominator? Correct, I can multiply this by 5. So multiply this by 5, multiply this by 5. So now 1 times 5 is 5. 6 times 5 is going to give me 30. Good job. So now, do my fractions have the same denominator or units? Correct. So now I can go ahead and start dividing. I know I have 30/5 divided by 18/5. So that's going to give me 30 divided by 18, which is 30/18. So can we rewrite this fraction now? Yes, This fraction is also equivalent to 5/3, or I can write it as 1 2/3. Good job. All right, students, in these problems, we were using what we already knew about equivalent fractions and the relationship between the part and the whole to solve the problems. We use common denominators to divide fractions. To make sure you've really got it, I'm going to let you try a few with me. Let's do 3 together to make sure you understand how we can use common denominators to divide fractions. So here are our 3 problems. All right, so let's start with problem 1. All right, so I know I need to change this to ninths. Since this unit is ninths, I can multiply this by 3. Since I did it to my denominator, I'll do it to my numerator, multiply that by 3 to give me 6 ninths divided by 3 ninths. So 6 ninths divided by 3 ninths. That's just 6 divided by 3, which is going to give me what? 2 as the answer. Good job. Let's look at the next one. I know I can change my mixed number to an improper fraction. So I'm going to change this to 6 fifths divided by 3 tenths. My denominators aren't the same, so I want to make sure that I can change them. So I'm going to change my fifths to tenths by multiplying by 2. And since I did it to my denominator, I'm going to make sure I do it to my numerator. That's going to give me 12 tenths divided by 3 tenths. So 12 tenths divided by 3 tenths. Yeah. So that'd be 12 divided by 3, which is going to be 4. Good job. So let's look at our last one. Change our mixed number to an improper fraction. So this be 5 halves divided by 5 eighths. I'm going to change this denominator unit to 8 so they can be the same. So I'm going to multiply that by what? 4. Good job. Multiply by 4. That'll be 20 eighths divided by 5 eighths. So 20 eighths divided by 5 8. Underline, circle. That's going to give me 20 divided by 5, which is going to give me 4. Good job. All right, great work. Today we reviewed dividing fractions, including mixed numbers. I hope you're seeing some of the connections to visual models and multiplication. You sure did do a great job. After the video, you will have some problems to practice on your own. You can find these problems at www.tn.gov/education. Good luck and do your best. I enjoy reviewing dividing fractions with you all. Thank you for inviting me into your home. I look forward to seeing you in the next Tennessee's at Home Learning Series. Goodbye.